So I have created a server. I'm just creating a server. So let me first give the IP address here. So here I'm giving IP address 0.2. Subnet mask is 255, and default gateway is this. And DNS server I am making it again this particular server, that is 0.2. So we can go to the configuration and services part. So let's add the HTTP server. Let's check this is on. Then we can go and see FTP server. Okay, this is also on. Cisco and Cisco is username, password, and DNS. Right. www.mc.com. Yes, sir. Yes. If I go and check it from PC1, I will be able to browse. I will be able to browse 192.168.0.2. That means, this server is working from this. So let me write few rules for the extended ACL, and then I will be, checking. I will be making the policy. First, this is what I am going to do. PC1 can or will not be able to access web server. Server is web server. Second, I'm writing PC2 will not be able to file server. So here I'm just writing it. This is as a file server. So PC2 will not be able to access file server. Now 3, the server is same. 3, I'm just writing PC3. So third policy I'm just creating here. PC3 will not be able to ping. I will not say access. I will say that ping the server. Ping the server. So 3 things I will be doing. So I have to deny PC1. So first, PC1 should not be able to get the access of server. So if you can go and see, now PC1 is able to access the server, that is 172.16.0.2. You can see this server is accessible. PC2, now go to PC2, go to desktop and type, FTP 172.16.0.2. Username is Cisco. Password is again, Cisco. So it was able to log in. So here in this case, we can see that this particular server was able to log into the file server. So now PC1, yes, please sir, if you have questions, please ask me, or else you can mute. Yes, Manoj sir, any question? Hello? No. Okay. Please do not unmute until unless it is required, because anyway this is in online, lot of noise issue create. So that's why. Thank you. So what I am trying to do is PC1 will not be able to access web server. PC2 will not be able to access file server. So I have just checked PC2 able to access. Now PC3 PC3, let me just go and check. PC3, I am going to check PC3 is able to access this or not. or rather I can make it PC5. PC5, let's see whether it's able to ping or not. Okay, fine. PC5 server is successful. So now where you have to enable? So PC5 from R2, this is the output of this particular one, that is gigaport 00. There I am going to implement because this server is connected to this port. And where I have to create this extended policy, that is in R2. So today I am going to create this policy for R2. So let's go and start. So I'm going to demonstrate the extended policy, ACL. First is enable, then config key, then access list 100, then now you see in the previous class when I was actually demonstrating the standard ACL. Standard ACL does not have this many features. The extended ACL, when I start writing access list 100 deny. So I am going to deny this server. So these are the options I am having. First is authentication header protocol. This is called IPv6 feature. I'm just not taking it. EIGRT. So if I wanted to block or deny EIGRT routing protocol for another router, I will be doing. GRE I have not discussed. Tomorrow I am going to discuss GRE tunneling. So this option is there. WSPF and again, so let's check this 4. So first and foremost I have to identify whether this kind of packet is under which category. So PC1 is not able to access web server. So this will be under TCP category. So if I would like to block the entire particular IP, so I will be choosing the option of IP. If I would like to block any other services like web service, file server service, okay, then I will be choosing TCP. There are very few cases, very few occasions we have UDP. Otherwise, like DNS and other services, you have to block both TCP and UDP. There you have to write a couple of codes, or we can actually block IP in that case. So here the first one we have to choose TCP. So let's choose TCP. So this is the first step what we have to do. So after typing TCP, again if I put question mark, this thing comes again. I have to what is my source address? So I can write here, that is host, the source address, that is PC1 IP address. You have to go and check the IP address of PC1, that is 192.168 0. Sorry, 10. So I have to write this is the host, that is this is my source. So first access list we have to write for the first one. I have to write, that is deny. So 100. Then I am writing deny. So same access list number we can use for all the three. So 100 we have to see. Then you have to check this is deny. Then TCP. Then host 192.168 0.10. Then next thing what I have to do, I have to choose the protocol, that is TCP. Then I have to specify what is my source. So here I have to specify both source and destination. So the source is 192.168.0.10 and destination will be host 172.16.0.2. Okay. If you write this line, after that what will happen? It will again say this is the incomplete command. Why? There is a reason. So after you write this, since you have chosen TCP, then again you have the option to have these many things here. Okay. So if you just press enter, it will not take, because you have to specify. What you have to specify? This is incomplete command. So you have to specify. That is, first is DCP, that is match packets with given DCP value. This is from TCP, DCP value if I am specifying. Or we can write equal to. That is equal to, I can write EQ, and then we can write www or port number. Okay, that we can do. We can also write greater than port number, less than port number, not equal to port number, value and range, then we have to press enter. So here in this case, if I write this particular line, so for example, here I am writing EQ port number 80. So it has taken. So I have specified the first line, that is, I am blocking this host. Okay, that is deny TCP. Now, second one is file server. So here I have to write file transfer protocol, that is FTP. But the host is different here. What is the host? TCP is the host. What is the IP address? 1.10. So I have to go and change, that is 1.10. Again I have to go and paste it. This is the second one. So again I am going and pasting it, the second one here. Then access list 100 deny TCP host 1.10. Now next we have to write, then again I am actually denying, but here in this case I will be writing ICMP. ICMP. After ICMP again I have to type host. So here in this case the next line is instead of TCP I have to type ICMP. What is ICMP? Because I have already told you that TC5 will not be able to ping the server. So I am going to block the ping of TC5. So let's go and pick it up, the IP address of TC5, that is 172.16.1.10. So 172.16.1.10. Then if I write like that, this will be blocking the ICMP packet. So echo is basically the ping packet. So let's write the paste and then put the question mark and write. So other than echo, we also have something that is called echo reply. Okay. So we can go and write echo reply also. Okay. Now, once we block everything, then we have to write access list 100, the last line, access list 100, because I have to allow others. So again I have to write permit, then I have to write IP, any. So this is the access list. Now this is the access list, the extended access list. So this will create the rule. So first one is basically, okay. So first one is basically for the first one, that is TC1 will not be. Yes, sir. Yes, Praveen sir, any question? Please do not unnecessarily unmute. This distract also, if you would like to take the session, you can take, or else, do not unmute. If you have any question, you can unmute. So this is extended ACL. The first one, this is the answer. Second one, this is the answer. third one, this is the answer, but at the same time, we have to write the last line, that is access list 100 IP any. The last line, access list 100. So, why I am writing, I have told you in the previous class also and previous sessions that whenever I am writing access list, it is implicit deny is there. So, that's why I have to make this, others as allowed. Then I have to go and keep the configuration in gigaport 00. There is what I have to write, that is IP access group. Then I have to write the number, that is 100, and then I have to write out. Okay. So this is the final function. That is finally we have to write this. So let me just go and paste it here. So we have to apply somewhere, that is interface gigaport 00, that is you can see. Then we have to write IP access group 100 out. So once you do that, then you will be able to go and check the policy. I am posting it in the chat box. So I will be giving you few exercises for extended ACL from the packet tracer. So this is basic, very basis of the extended ACL. So this is how you can actually do it. Now I've actually demonstrated the extended ACL part. Now what we can do, we can go and check it. If you go and type that 172.16.0.2, you can see this is not accessible. Whereas, okay, this can be accessible from any other desktop. So you can go and see 172.16.0.2. I'm just denying host this one. Okay. Request timeout. I have to go and check what is the issue. PC1. Okay. Command prompt I should able to ping 172.16.0.2. The reason you have to find out because I've already written IP access permit access list 100 permit IP any. Okay, let's verify and check. So access list, if I type here access list, okay, the first line is basically denying 192.168.0.10. So once I write this should be having that allowing of others. So here in this case, there can be some issues. Let's go and see if it is able to ping from others or not. So let's go and ping it from here. So ping 172.16.0.2. Maybe it is clashing with other access lists, but this particular one very much. Yes. So let's just do the exercise from the NAT attack. So let me just give you a quick recap from NAT attack itself. So let me go and log into NAT attack and take you through that ACL. So today I'm going to do a quick recap on ACL, and then I'll be downloading that ACL exercise and use it to you. Then I will be moving to the Then I'll be moving to the next part and do it. So let's see. So let me just open this and let's go to the packet tracer. Let's go to the chapter. So we are having this chapter is all about ACL, that is how we can provide a security in the network. So in terms of blocking a particular host or blocking any other network from the outside, we'll be able to block others. So that's what I'm going to show. So that's why we are taking ACL. So this is ACL part. So this is the topology I'm just going to close and I'm going to open other topology because this topology, whatever I have designed, you can go and create. So let's go and see. The theory, ACL is basically to block the traffic. So we can actually do we can do the filtering at transport and network layer, we have seen. And we are having two types of ACL, standard and extended ACL. In ACL, we are having two types of implementation. One is inbound and one is outbound. So here in this topology, we have done outbound ACL because outbound ACL is basically implemented for extended part because we need to implement nearer to the destination, and inbound ACL because it should be nearer to the source, and that is how it is. Now you can go and download this ACL demonstration. So I'm actually downloading this packet tracer file, and I would request you to practice it. So what I'm doing, I'm just posting it in the chat box of our group. So please go through this WhatsApp one. So this couple of ACL demonstrations I am uploading. So finally, I will be giving you few packet tracer activities. The first one is this one. I will request you to complete this ACL exercise so that you will be able to understand how ACL works. So that's so I am just giving you this packet tracer. So this packet tracer activity will help you to understand how you are going to implement this ACL. So it is asking, this is the topology. This topology is created, so you have to create this topology first. So this topology is created there. After that, it is saying that first you check TC1 to TC4, you should be able to ping. Then TC1 to DNS server, you should be able to ping. Then after that, you go and check the access list. So this is the standard access list 11. It is created. So after that, you have to verify this, this permit and deny. So if you would like to remove the access list, what you have to do, you have to go to the interface and write no IP access list this, and then you have to write no access list, and when you write no access list 11, this will be removed. After that, you need to again check it. Again, you have to create that ACL and test it out whether this is working or not. This is for the standard ACL, and very small PT activity is there for checking the first one. Then I'm moving to the next one. So this is the standard ACL. Wildcard mask I have already covered. So just go through this. But whenever you are creating this access list, so Just go and see these couple of lines. In case of any access list, for example, you are creating access list here. Couple of access list examples are there. When you write permit, then when you don't write host, this also you can mention. Okay. So instead of writing permit IP any, you can write this, or permit, instead of writing host, you can write this, and wildcard. Subnet mask can be for any host, it is 255.255.255.255. So wildcard mask will be 0.0.0.0. Instead of, if you don't want to use the keyword host, you still will be able to write this. So up to you, it is up to your choice, and this is for any. This is the alternate solution. So I'm just covering this up now. Now, this is basically demonstrated you that how this IPv4 and IPv6 it works. So I'll just come and discuss that IPv6. So instead of IPv6 and IPv4, the difference is the access list is same. You have to just specify the IPv6 ACL. There is no other difference. So standard and extended ACL, I have given you a small demonstration. So you have to go and check it. So this is the topology. You can actually check this topology, and in this topology you have been asked to design a standard and extended ACL. So standard and extended ACL has been explained here. Now what you have to do, you have to go and configure this. So the configuration part is basically elaborated here. So now what you can do in extended ACL, you can have, you can also block this telnet also, securing VTY ports with standard and extended ACL. So first you have been given a the demonstration of creating a standard ACL, and then you have to go and demonstrate a extended ACL. So you have to go and see, this is the syntax of IPv4 and IPv6 ACL. So both are same. So this is the packet tracer file. So I'm just downloading this packet tracer file. In this first packet tracer file, you have been asked to do some basic configuration. So this configuration I am just giving it to you. You need to just practice and get back to me. If you can do it right now, it is very good. Otherwise, first one is numbered ACL and second one is named ACL. That yesterday I have demonstrated. You have to go and practice this. So this is the topology and this is the exercise. I would request you to complete this one. And after that, you have been given same thing you can apply for VTY. So in that, what you have to do, you have to, instead of typing IP access group, okay. So here in this case, what you have to do, you have to go and modify this for VTY. So this modification part is basically demonstrated here. So what you have to do, you have to go to line port, okay, and then this is the named ACL. So here in this case you can see the name is used. So in named ACL also or numbered ACL also the same thing happens. So here it is asked to create a numbered ACL, and after that you have been asked to create a VTY, that is telnet port. So you can actually go and create or rather secure telnet. So what you have to do, you have to write this line. So I'm just going to show you here. So here in this case you can see first you have to create a username and password. Then you have to check this is how you can secure your line VTY ports. Okay. So is the configuration, and I will request all of you to go through this configuration which I am sending it here in the chat box. Okay, this is the standard ACL for line VTI. This is same, but you will be able to see that we will be able to restrict other users other than a very authenticated user. Okay. Then next step is to configure the extended ACL, which I have covered here. So this is the way you can configure. That is standard and extended ACL. The difference is here. It is per port, per protocol, and per host. Okay. So this is my destination. So I can actually set a different port and protocol for TC1, different port and protocol for TC2, and that is the difference. Okay. So here in this case, this is basically demonstrated. Here in this case, you can go and check. The same thing has been demonstrated here with a named ACL. So this is basically named extended ACL example. So I would request all of you to go through it. I'm just going to post this here. So what I can do, I can actually go and post this configuration part. So this configuration part I'm downloading and posting it here. So this is the first scenario, and I'm just corresponding one I'm posting. So this is the configuration of extended ACL. So I will request you, all of you, to go through this post of both standard and extended ACL. Okay. So I'm just posting it in the chat box. Just give me a second. Okay. So once you complete that, we'll be now covering the next part. So just give me a second. Let me post those files here. Let me post those files here in there. So I would request all of you to go through this extended ACL and standard ACL files. Please download and practice now. I'll be giving, after I complete NAT, I'll be giving a time. All of you can go and practice this part. Okay. So any question? Anyone have any question can ask me, or else I will be going for the NAT. Okay. So what do you mean by NAT? Yes, sir. Hello? Yes, sir. You are asking something? Hello? If you do not have any query or any question, we are moving to the next part. That is the part of, NAT.
हेलो
Yes, sir. Yes, sir.
यस सर सर मेरा एक क्वेश्चन है इसलिए कि आई वांट टू इम्प्लीमेंट एक्सटेंडेड एसीएल फॉर restricting some of routing protocol updates, right?
Yes.
In terms of OSPF, in terms of EIGRP.
Yes.
So if you show some lab, so ये बहुत बेनिफिट होगा हम लोग के लिए या काफी फ्रूटफुल होएगा.
Okay, because routing part is not there in our CCNA syllabus. If you want, last day I will just cover a small topic on routing.
OSPF एक OSPF हम लोग इम्प्लीमेंट कर लेते हैं जिसमें 2 एरिया डिवाइड कर लेते हैं और फिर
Yes.
इम्प्लीमेंट
So that is the last part. So I will just come and because this last part here there is something. So maybe today, not today. I'm planning it on Monday because that is the extended part. So we have to create that advanced topic. So that advanced topic we'll do it on Monday. Just remind me. I'll be taking a session. That is the last session. That configuration of multi-area WSPF and block that multi-area WSPF with a extended ACL that you want, right? So we'll be doing that. Okay, we'll be doing that. So remaining the topics which I have covered, if you have any question, you can ask me. Okay, so let's start NAT. What do you mean by NAT? NAT is a network address translation. So for example, if you are creating regarding NAT, NAT is basically network address translation. For example, we do routing, right? So, why we need to do routing? Because one router does not have that routing table information of the other router. So that's why we basically need to configure a routing, right? Now, my question is, why I need to, if I do a routing, why I need to do netting? See, the concept of this is I am having two types of network. One is called home network and one is called internet. Now, if you are connected to internet, okay, then your home network is having a different network and internet is a different network. Now, whenever you do routing, okay, your request will never be processed because your IP address, that is a local IP address, home network IP address, is always a private address. But if you wanted to get connected to internet, you need to have a public address. So, some proxy server or any server need to do a proxy for you. But that's a typically proxy server configuration. What I want from my computer, the request goes directly. So whenever my request comes, okay, the gateway needs to translate that request to a global request. That means my home network address needs to be converted to a public address. So there are two things. If I type IP config, the IP address I am getting for the local. If you go and type what is my IP in the browser, you will be getting a global address. So this local IP config address is basically, if I am having internet connection, is basically converted to that public IP address. That's the public IP address, and this public IP address is basically the resolved address, right? Now let's see how we do it. Let's understand the NAT characteristics. For example, if you go and see, this is my internal address. So this is my private IP address space, and this is my public IP address space. So private IP address spaces, I am having any of these three IP addresses, that is class A, class B, class C. Because these are my private addresses. This will never be used for public addressing. So NAT is basically what it is doing. So this is my private address space. So when the request comes to the router, if we have NAT enabled router, then only that request will be sent to the public. Because in public address space, in the public cloud, or in the network, internet, we do not know where the host is. So that request will be going to the ISP. ISP again will do the resolution because from source to destination. That's how we can actually go and type it in the command prompt. For example, if I write trace root www.google.com, my request or query is basically getting resolved by, So this is my local host, that is 192.168.0.0. Then it is going to the local ISP, from that global ISP, and finally with some several 15-20 hop counts, I am actually reachable to the server. So basically this DNS and NAT will help me to reach to that public server. So how NAT works? Let's see. So my request goes. Now this request in fact particularly will be having the inside local addresses, then it will be converted to inside global addresses, then ISP will be connecting to the outside local addresses, and this is the finally outside global addresses who is sending my or taking my request to that particular server. So when it reaches, it will respond back to me. So this request again comes to my local PC, and this is how we have actually this NAT table is created, that is one-to-one corresponding from source to destination. So that is basically NAT. Okay. So NAT includes 4 types of addresses. Inside local address. What is the inside local address? This is the inside local address. Inside global address, that is the IP address of the ISP, which is giving me the connection to the internet. Then outside local address, this outside local address, then the ISP is basically taking me to the globe, means that is further connected to the global address. So this is which is helping me to do the resolution. So here this is the inside local address. It is not resolving because maybe some ping issues are there. Otherwise, it would have taken you to that. Okay. So let's see just. It is taking time. I do not know what is the reason. Otherwise, I can actually go and type another Google dot. Let's see Google dot co.in. It is resolving fast. Progress is there. It will take some time, but here in this case, I do not know, but it should give the resolution. So just check it out. So this is how a NAT table works. So here in this case, you can see this is my inside addresses. So we are having inside local and outside local address through my ISP. And after that, this packet, when it goes beyond the network, there will be outside local and outside global address. This is not my lookout. That is basically done by the server when it is searching for a specific internet or specific addresses. So how you can configure the types of NAT? You can configure static NAT, one-to-one. Just writing static NAT, okay, IP NAT, this address with this address. You can do the resolution. Or you can go for a port address translation, that is a dynamic address resolution. So you are having ISPs providing a pool of addresses. So your all requests are going parallelly. So there you are using the port number. So you can see every request comes with the port number. So this is your local port, this is the inside local port, this is inside global port, then outside local port, and then outside global port. And that is how this NAT table is basically working, so that through port you can have, or you can basically maintain each and every session separately. When you are maintaining each and every session separately, that is how NAT works. So the NAT and PAT comparison is, it will be working through port. So just download and investigate. This is the configuration command. So this configuration command, okay, you can actually go and check it. So the NAT translation, you have to go and configure. So let's go and see the static NAT scenario. In static NAT scenario, this is your local address and this is your global address. So just you have to configure, that is, here in this case, you can see the configuration is something like that. The home network address, when you write this configuration, enable config IP NAT source inside static, your local address to the global address. So one-to-one correspondence is done by this configuration. This is called static NAT configuration. So IP NAT inside source static, that is the configuration. Next is, you are making a little different, that is dynamic. So you decide on that router what is your dynamic ports and all. So the second step is dynamic one. So first, this is the router one. So interface serial 010. Here, this is your, for example, this is connected to the home network. So this is your home network. So you can specify this is IP NAT inside, and then this is, you have to specify this is IP NAT outside. So you have to just give the IP address, this is inside NAT and this is outside NAT. Then after that, what you have to do, you have to do the mapping. So how you can do the mapping? You have to just say this, that is IP NAT inside source, then you have to write serial 000 and then destination port, destination IP is this. So source you have to specify and destination you have to specify. And this is your source and this is your destination. Then you will be able to do the configuration. So that is configuration of static NAT. You can go and see. This is how you can configure the static NAT. Okay. So this is IP source NAT inside source static, and then you have to specify what is your inside and what is your outside NAT. After that, once you specify this port also and this IP address. Okay. So you can actually write the static keyword, or else you can specify the port number. So that is how you will be able to configure this. This is the very basic configuration. So this is my home network and this is my outside network, and after that, once I configure that, I will be writing IP NAT. This is as a inside, this is as outside, and then do the mapping. So this is my static NAT configuration. And if I want to do dynamic NAT, I just need to specify that. Again, configuring dynamic NAT. So in dynamic NAT, what you have to do, you have to create a pool, LAN pool. So just go and see the difference. First, I have to go and create a NAT pool. That is, this NAT pool will be of the global addresses. So you can see this is not the entire, all the IP addresses. For example, ISP is providing me this pool, that is 226 to 240. So I'll be using this for the dynamic address. So I have to create that NAT pool. Once I create that NAT pool, then I have to do the translation. Then I have to do that configuration. So just go and see the configuration. So the first part is same, that is, you have to mention what is your inside and outside. And after that, instead of writing this line, you have to write this IP NAT pool. And after that, you have to mention, that is, what is your inside source and what is your outside source. So IP NAT, okay, pool. Then you have to mention what is your inside port and what is your global port. So after that, you will be able to do the configuration. So now, this is the configuration of dynamic NAT. Now next is PAT, port address translation. So port address translation is basically you need to use a little more, that is with the keyword. So you can actually, here in this case, you have to say that IP NAT inside source, then you have to create a ACL. This is basically ACL list. So this ACL list first will be created, and ACL list will be only single list will be created, and then this ACL is basically implemented over, this is my source list and the outside, NAT inside and outside. That outside can be with the pull or with that overload command. So there you have to specifically create that. So now you can see there you need to specifically create that. Okay. So serial interface, IP address you have given. You have to tell what is my inside, what is my outside port. Once I do that, I will be able to configure that. So this is the configuration. So once you come to create the configuration, you have to go and see, that is NAT for IPv6. Normally, by default, NAT is active in IPv6, So no need to do that. Otherwise, we have to go and check it. Okay. So here I am just closing my lecture. Anyone having any doubts can ask me, or else I can go and start the discussion tomorrow. Tomorrow we will be discussing about the concept, that is VPN. So we will be discussing the VPN concept. So we will be checking types of VPN, IPsec and tunneling. So GRD tunneling and all. So tomorrow I will be taking one more class. Friday and all will be taken over by Nitin sir.